how the divided differences can be explained. Divided differences. If we have fx naught, x1, x2, this can be expanded by fx naught upon two brackets plus fx1 upon two brackets plus fx2 upon two brackets. What these two brackets are, if it is x naught, so x naught minus x1 will be the first bracket and x naught minus x2 will be the second one. And if it is x1, so x1 minus x naught will be the first bracket and x1 minus x2 will be the second bracket. If it is x2, then we have x2 minus x naught will be the first bracket and x2 minus x1 will be the second bracket. So only x2 minus x2 is not there, x1 minus x naught, x1 minus x1 is not there, x naught minus x naught is not there. Otherwise, all the differences we will have. In the same way, if we want to expand f x naught, x1, x2, and so on, xn, we call it as nth order first entry of nth order divided is basically the first entry of nth order divided differences. How this first entry be expanded? This can be expanded by fx naught. In denominator, we have all brackets. What all brackets we have in denominator? X naught minus x1 up to x naught minus xn. All of these brackets we must have. Then second term we have fx1 and all brackets we have in denominator except only x1 minus x1. So x1 minus x naught, only x1 minus x1 is missing and we have x1 minus x2 and remaining all brackets we have x1 minus xn and so on. In the same way we have to proceed and the last term will be fxn divided by xn minus x naught. All brackets we have except only xn minus xn. So this is xn minus xn minus 1. So this is called first entry of nth order divided difference. The first order divided difference can be write down in this way. This is the first formula. This formula is used to estimate an unknown entry corresponding to a given argument. Second formula is called Newton divided difference formula. Newton divided difference formula is used to estimate a missing entry corresponding to a given argument whenever the arguments are unequally spaced. So it is used for unequally spaced arguments And the first one is used for equal spaced arguments. So equal spaced arguments and unequal spaced arguments, these are the two important thing that we must have to consider whenever we are going to interpolate an item in the entries y. This is number one. Newton formula for equal spaced argument. This formula is fx is equal to y naught plus x minus x naught delta y naught upon 1 factorial h plus x minus x naught x minus x1 delta square y naught upon 2 factorial h की power 2 plus x minus x naught x minus x1 x minus x2 delta की power 3 y naught divided by 3 factorial h की power 3. In the same way, we have to proceed for the nth term, and the last term will be what? Last term will be x minus x naught, x minus x1, and so on, x minus xn minus 1, delta की power n, y naught divided by n factorial h की power n. This formula is known as Newton formula for equal spaced arguments. Our data is given to us. In this data, we have two variables. One variable is the temperature, which is an independent variable, and another variable is y. This is the dependent variable, viscosity, and different values given here for temperature, and 1, 2, 3, 4 values are given here. Arguments are equal spaced. If a argument is given to us, that argument is 8. Against 8, the viscosity is missing. So we have to estimate the viscosity against 8. Or if a temperature of 4 degrees centigrade is given to you, you have to estimate the viscosity at 4. So different values of x are given to us, and we have to estimate the viscosity at the given values of x. So this is the problem. For solving this problem, we have to use Newton forward formula for equal space argument, and we have to construct a simple difference table because the arguments are equal spaced. How simple difference table can be constructed? The first column will be the delta y, and this can be calculated simply by differencing. So you have to take the difference of these two. This difference is known as delta y naught. This difference is known as delta y1. So you have to calculate these differences. I am writing these differences here. This is delta y2. Now we are going to construct the next column, second order simple differences. This is represented by delta square y.
सर पहली वाली वैल्यू का आंसर नेगेटिव में आएगा ना?
1.5 minus this. Yes, this is negative answer. Now we have to calculate the delta square y naught, and this is called delta square y1. The 0.211 plus 0.273. Instead of minus, we will have a plus sign because this is already negative. And 0.16 minus 0.21. And the next column will be delta Q column. What are the answers? In this simple difference table, if we have the four observations, I told you earlier, if we have the four observations, then the third order simple differences will be constant, and the fourth order and higher order differences will be zero. So you can observe it here. Now, what is the objective? We have to find y for x is equal to 8. Once I told you x is equal to 4, then I told you x is equal to 8. So two times I am going to solve the problem. So why the formula fx is equal to y naught plus x minus x naught and delta y naught upon 1 factorial h की power 1 plus x minus x naught x minus x1 delta की power 2 y naught divided by 2 factorial h की power 2 plus x minus x naught x minus x1 delta की power 3 y naught upon 3 factorial h की power 3. And remaining term, what will be the delta for y naught? That will be 0. So we have to restrain the formula up to only these four terms. Now we have to plug in these values. Y naught, the value of y naught is this. This is the value of y naught. First entry, 1.79. 1.792 plus the value of x. The value of x is 4. And the value of x naught 0. This is the value of x naught. It is 0. Now you have to put the delta y naught. This is the value of delta y naught minus 0.273 divided by 1 factorial is 1. H raised to the power 1. What is h? H is 5. H is the difference between these two arguments, 5 minus 0, 10 minus 5, 15 minus 10. So this is the difference in between the arguments. So H is 5 plus x minus x naught. X is 4, x naught is 0, x is 4, x1 is 5. This is your x1. And now delta square y naught, this is delta square y naught, 0.062. So 0.062 is to be plugged in here, divided by 2 factorial h square. H is 5. 5 square. Plus x minus x naught. X is 4. X naught is 0. One more bracket I should have here. X minus x2. Because every time one bracket will be added. X4 minus 0, 4 minus 5, 4 minus 10. Then we have delta Q. This is minus 0.019. 0.019 divided by 3 factorial h cube. 5 cube. Now you have to find the answer of this. Answer is 1.5638, and we can observe this number is increasing and values of y is decreasing. So you can observe 1.7, 1.5, 1.3, 1.1. So our output will be in between these two. So you can observe 1.56, I think, is the most appropriate answer because it is very closer to the 1.5. So as expected. So this is the answer which is here. If we have to estimate F8 as given in the question, so what you should have to change? Nothing. You have to change this x only. Instead of 4, we have 8. Instead of 4, we have 8. Here we have 8. Here we have 8, and so on. All over there we have 8. If all over there we have 8, so we can change the value of y, and that y will be the output against 8. Instead of using this formula for estimating the 8, I suggest you the central differences. So there are the another type of differences we have, and that type of differences is known as central differences. If your missing number is from the center, so instead of simple differences, we will use central differences. If your missing number is from the beginning, so we use Newton forward formula. If our missing number is from the bottom here, if I want to estimate 14, so 14 can be done by Newton backward formula. So there are the two further categories: Newton forward formula, Newton backward formula, and central difference formula. If missing number from the bottom top, Newton forward formula can be used. If missing number from the bottom, Newton backward formula will be used. If missing number from the center, central difference formulas will be used. शुरू में दी थी, divided differences can be expanded by, and that can be represented by fx naught x1 is equal to fx1 minus fx naught divided by x1 minus x naught. This is called first entry of first order divided difference. This is written here. This can also be written as y1 minus y naught upon x1 minus x naught. So you can see that this is the formula of slope. Y1 minus y naught upon x1 minus x naught is what? This is the formula of slope. Now fx naught x1 x2 fx1 x2 minus fx naught x1 divided by x2 minus x naught. Similarly, if we have all arguments x naught to xk, then first you have to write down, skip first one, all of these should be here, and then skip the last one, all of these are here, divided by xk minus x naught. So this is the way of expanding the divided differences. I already explained the divided differences in the previous lecture. Now this formula is known as divided difference formula. So what you have to do for a divided difference formula, you have to use this formula. This is the formula which is summarized in the form of sigma. I can write down this formula in the expanded form. Expanded form will be what? Expanded form will be f n x is equal to uh, 0 to I minus 1. Suppose we are putting as I as 1. If we put I as 1, so we have fx naught only. And if we are putting I as 1, I as 0, this is 0 to minus 1, so there is nothing. So your first value will be what? Your first value will be fx naught. plus x minus x naught f x naught x1 plus x minus x naught x minus x1 f x naught x1 x2 and so on. In the same way you have to proceed. It will be the x minus x naught x minus x1 and so on, ax minus x n minus 1 f x naught x1 up to xn. So this formula is known as Newton divided difference formula. So what difference you are observing in between this and the previous formula? Instead of simple differences delta y naught upon 1 factorial h, instead of formula we have delta square y naught upon 1 factorial h square. So we have to put the divided differences here. So these are the divided differences. Fx naught x1 is what? This is divided difference, this is divided difference, this is divided difference. So we have to use the divided differences here. So I will explain the divided differences, Newton divided difference formula in detail in the next lecture. So I'm going to pause this lecture here and will continue the lecture of Newton divided difference formula in the next lecture.